Good morning, everyone. My name is Blake Wyseth, the Applied Research Lead at the Glacier Farm Media Discovery Farm Langham. And I want to thank you all for joining our webinar presentation this morning, where we will be talking about easy wins in precision ag using examples from our Field of Excellence project at the Glacier Farm Media Discovery Farm this year. Now, for this webinar, we've assembled an expert team of panelists who I'll be introducing very shortly. And they'll be able to provide a broad perspective of the topic of precision agriculture. And we'll be focusing really on the fact that precision agriculture encompasses a lot of things. It means different things to different people. There's a number of different practices and technologies that fall under precision ag. And in our experience at Discovery Farm, some of these practices are quite easy to implement on the farm. On the other hand, there's practices that take a lot more effort, and there's barriers to adopt them for a number of reasons, be it the capital investment required to implement the technology or the added logistical considerations. So with that, those two perspectives in mind, I hope we're going to have a nice balanced conversation hearing from our panelists and really describing the types of examples that we had at our Field of Excellence project at Discovery Farm. So with that said, I'll lead right into our project at Discovery Farm. This is our Field of Excellence project. And at the start, I just want to acknowledge all of our industry partners that came together to make this project a reality. And you can see those on the bottom of the screen with the various logos. So thank you to those industry partners. Now, in terms of context at the Field of Excellence project, this is, we had it conducted over 180 acres at the Discovery Farm located west of Langham, Saskatchewan. It was split between two crops, and you can see this on the satellite image on the screen. So we had 120 acres of wheat on the north end of the field, and then 60 acres of canola on the south end. Now, the image that's overlain on top of the satellite image, that's a SWOT map that we were able to use in partnership with CropPro Consulting. And it really served as the base data layer for a number of the precision ag practices that we implemented. And one of our panelists, Wes Anderson with CropPro, I'm sure he'll speak more about the SWOT map once we hear from him in the questions that I have pre-prepared for him. We also had other hardware installed in the field through our partnership with Metos Canada that served as additional data layers. So you can see on the screen here, we had soil moisture probes, precipitation gauges, and weather stations for localized weather data. And collectively, that provided a lot of data to help us inform the decisions that we were making. So for the rest of the presentation, I'm going to be speaking of some of these examples of precision ag that we implemented, and I've grouped them into different categories based on our experience of really how easy it was to implement them. And so again, I'm hoping through this conversation and the panelist questions that we'll have shortly, maybe for those farmers and attendees on this panel, it'll help you to see, if you're interested in exploring precision ag or getting started, where are maybe some of those easy, quick wins you can get started. And maybe there's other people on attending that are, more experienced with precision ag and are looking for additional wins that they may not have even considered before. So first, in terms of our easy wins, the first example is how we did a variable rate top dress UAN application for both of our crops. And so what you see here on the screen on the left side is the available water map that was built for us by CropPro Consulting using their SWOT map along with the soil moisture probes that we had installed in the field. And what this does, it models available water across the entire field. Now, this map was generated on June 22nd. And so once you know that estimated available water, you can predict your crop's estimated nitrogen demand. So that translated into the prescription that is on the right side of the screen. This dives a little bit deeper into the prescription. So this is showing what we prescribe for our wheat field. So across our 10 zones on the left side, and layer 1 is our UAN application rate in gallons per acre. So in zone 10 as an example, this is our typical depression areas in the field, high residual fertility, periodically flooded, possibly saline. So we chose not to apply any product in that zone, but for our other zones, we varied our rate from 5 up to 9 gallons per acre. And we did a similar exercise in our canola field as well. This time we chose not to apply product in zones 9 and 10, but we had it vary from 5 up to 12 gallons per acre in the other zones. And so the reason why I say this is an easy win in my perspective is, once we had that prescription developed, it was simply a matter of loading it onto your sprayer's controller and away you go. We had a dual nozzle setup, and so that was able to apply the range of rates in a single pass. And really, it just allowed us to have a nice, easy win. Now, the limitation, of course, is, the resolution that you're going to apply this prescription is limited by the capabilities of your sprayer. So in our case, working with Apache, we had sectional control in 16 sections across the width of the boom. And so we had the ability to apply a unique rate at each of those 16 sections. The second example of the easy win is our on-off fungicide prescription that we applied. So this, we are looking at our wheat field, and the single data layer we use is an NDVI image. In this case, it was taken on July 11th, so you can see that on the left side of the screen. The brown areas, again, represent these zone 10s in our field. So again, it's the, periodically flooded zones, possibly saline. So we're seeing poor crop growth. And so the prescription that is developed on the right side of the image shows this on-off prescription. So we chose to apply a fixed rate, 12 gallons per acre of water across the majority of the field, but we shut it off in that zone 10. And by doing so, we saved applying on nearly 6% of the field. We also did the same thing for our canola field. So here we're seeing, again, that NDVI image on the left side. This case, it was taken on July 4th. And the prescription on the right is similar. We shut it off in zone 10, but applied it at a constant rate on the other zones. And in this case, we saved nearly 8% of the field. So again, the reason why I say this was an easy win is it's an instance where again, it's just a matter of loading that prescription on the controller, away you go, and you're able to save inputs and you're able to apply those inputs where they're most needed. So the second category is what I've called kind of easy wins. And the example here is the SWOT-CAM technology that we were able to use, again, in partnership with CropPro Consulting. So how this works is there's a camera attached to an ATV, and they drive throughout the field and capture literally thousands of images that you can feed into a machine learning program that calculates the percent of leaf area of the crop and the weed species. So when you plot that by the zones, you see that your weed leaf area or your crop leaf area is quite consistent across the field, but your weed leaf area varies quite drastically. In zone 1, we saw values of about 4% area up to nearly 17% in zone 10. So where you see this nice correlation between your weed leaf area and zones, it allows you to develop a prescription that you can apply according to those management zones. This slide shows the process of how CropPro went about developing that prescription. So on the left, we have the weed leaf area map. You can see the variation. And then on the right, we have the prescription that was developed. So, for the majority of the field, the areas where the weed pressure isn't that intense, we had our standard application rate of applying a 10 gallon per acre water volume. This results in 1.35 liters per acre of product. However, in the high weed density zones, we bump that water volume up to 12 gallons per acre, which results in the application of 1.62 liters per acre. So again, this is a really easy win where we're getting good control of the weed species by simply, loading that prescription onto your controller. I'm going to share a video of the sprayer and how this prescription was applied. So just bear with me very quickly as I share my screen and show the video. So in this video, we're in the sprayer and we're going to be starting in an area where we're seeing quite intense kochia pressure in the field. Going to the monitor, that purple polygon is the high application rate of 12 gallons per acre of water. And as we go down to the green polygon, we're dropping our application rate. And as we pan back to the field, you see quite clearly that the weed pressure is much lower. And the only reason why I said that it was kind of easy win, just speaks to the amount of manual data collection that's involved, not by the farmer, but by the agronomist to build that prescription. I guess I might have to stop this presentation and start it again. I can't advance my slides. Just bear with me here, folks. So just going back to the last slide. Okay. And now for the last category, I've called it wins that take some work. And the example that I'm using is the fertility prescription that we applied at the time of seeding. So we were fortunate to work with Vaterstad Industries for the drill, and they do have quite an incredible machine with a lot of technology. You know, the air cart has 4 compartments in the air cart, and you can have 4 products applied, each at a unique rate, and they're metered very precisely and placed very precisely according to where you want it. So this screen shows what we did for our wheat field. So we have variable rate of seed and 3 fertilizer blends according to the various zones. We did a similar exercise again with the canola, where we had again, our variable rate seed along with the 3 layers of fertilizer. So again, this is, it resulted in quite an easy win in that we're, able to do our best at applying the inputs where we think they're most needed. But I do acknowledge that it does take some work to manage the logistics associated with it. You're dealing with several different blends and needing to load those and store them separately, and also bearing in mind that we were just dealing with 180 acres in our site, and not also considering the added logistics when you scale that up much larger. So finally, let's just look at the harvest and the yield data where it all kind of culminates. So what we're seeing here is in our wheat data, we have our different zones, our revenue and our cost, but most importantly, the profit. So as we expect, our highest profit was in those middle zones in the field. In the upper zones, we were able to still see respectable profits, I would say. And this is largely due to our ability to dial back our fertilizer and our inputs in those high zones where we see residual fertility. In the upper zones, we saw still respectable profits, but largely here it was more of a moisture limitation that negatively impacted yield rather than a fertility limitation. And finally, this is our canola yield data. So again, by the various zones, and similarly to the wheat, again, our highest profits were in those middle zones in the field, still respectable profits in the upper zones because we were able to dial back our inputs in those zones. So with that, that kind of sums up what we did at Discovery Farm in terms of precision ag practices. And now I'll stop my presentation and I'll shift to the portion of the presentation where we're going to be hearing from our panelists. So with that, I will just introduce all the panelists for you. And in no particular order, we have Lauren Grieger. Lauren is joining us from the Prairie Agricultural Machinery Institute. Most of you know PAMI, of course. He is an engineer at PAMI, and he is very much involved in the research projects that are happening at PAMI. So for the sake of time, I'll leave the introduction and his introduction at that, but all the panelists are certainly welcome to elaborate on who they are when they have the chance to speak. Secondly, to hear from the sort of perspective of a farmer, we will be hearing from Bryce Moore. So Bryce currently farms in the Leroy, Saskatchewan area. He has training from the U of S College of Agriculture. And in addition to bringing his perspective as a farmer, Bryce also consults as an agrologist with his own consulting company, as well as working with Western Ag Labs using their services, and currently has an affiliation with Synergy Ag as well. So thank you, Bryce, for joining us. And finally, we have Wes Anderson. I mentioned him in our presentation. Wes is coming to us from Crop Pro Consulting. He originally comes from a mixed farm near Theodore, Saskatchewan, but is currently the VP of Agronomy with Crop Pro Consulting. So again, with that, I just want to thank all of our panelists. So in terms of the format now for the duration of the presentation, I have a few questions that I've prepared in advance for the panelists. I would encourage anyone that is attending this presentation that they are certainly welcome to put comments in the chat function and questions as they come to mind throughout the presentation. And we hope to address those at the end of the presentation when there's time. So with that, for the first question, I'm going to go to Wes Anderson. And Wes, from your experience working with various clients, what are some of the best easy wins precision ag practices that you've seen implemented on farm?
Yeah, thanks, Blake. Yeah, I would probably agree with a lot of your analysis there at the start of your presentation. I mean, there's things that are really easy to implement. VR fungicide, I think, would be one that's just so simple relative to everything we do. A lot of the time, it's an NDVI image is a good base layer, because it really what we're looking for with that sort of application is just where is the crop poor and doesn't justify a fungicide, right? And it doesn't matter why it's poor in that case. So that's where NDVI is quite useful and easy, cheap to get. Frankly, there's multiple platforms that you could even utilize. I mean, farmers might even be able to do that themselves using a platform like Climate Field View. It's something we're able to offer through our platform as well with crop records. But yeah, very easy to do, and actually as an on-off prescription can be applied at a really high resolution too, taking advantage of sectional on-off control on most sprayers today. So on the fertility side, it does tend to get more complicated, like you kind of alluded to, right? You're sort of starting to balance logistics and stuff with agronomy, and sometimes what I want to do isn't always necessarily possible due to logistics. But we got to be careful not to overthink it too. And a really easy win, I think, for a lot of landscapes across Western Canada in particular is salinity, right? Those saline areas, like ideally we just don't farm them, but the reality is there's little pockets of artesian discharge that are just easier to farm through rather than turn around. And those areas just always have heaps and heaps of nutrients. The yield potential is always going to be poor because it's salt limited, right? And those are easy areas to start pulling back on nutrition and cutting costs, like you showed in your economic analysis, and try and maintain some sort of profit, right? There's just no point in pouring on a bunch of fertilizer in those areas, because not only for economic reasons, but environmental reasons. Similar to that, actually, in the north, in the black and gray wooded soil zones, we run into areas with peat depressions or muck depressions, so very high organic matter soils. Again, the mineralization potential is just massive in those areas, and it causes issues with lodging often, right? It's the challenge in those sort of areas are often just to keep the crop standing. And again, a really good opportunity to cut back nitrogen, often for several years in a row. And actually grow better crop. So those are some really easy ones. You'd mentioned the herbicide, the Liberty VR Liberty app. While there was some, it took a bit of work to produce that the prescription for you this year. Going forward, that product as it develops may become one of the easiest things we do. Actually, I mean, we're intending on automating that.
Perfect. Thanks so much, Wes. Bryce, posing the question to you and hoping you can put on your farmer hat here. Recognizing that, again, precision ag means a lot of things to different people, and I don't want to limit it strictly to the practices we talked about, but I'm wondering, how have you implemented precision ag on your farm so far?
For sure. Thanks, Blake. Yeah, so not a real large farm. And some other limitations I'll get into later, but basically, variable rate doesn't have to be fancy equipment. We're doing some manual variable rate on the farm. We have some land that has some, moderately saline areas, obviously not as productive. We can separate those areas, treat them almost as a separate field within the field. Cutting back on fertilizer, as Wes talked, increasing seeding rate has really helped those areas out. treating those areas the same way that you treat the rest of the field sometimes will increase the issues on those areas. We're trying to remediate those soils if they can be remediated. A big part of farming is maximizing the efficiency of your dollars spent as well. So that's what we're trying to do with that is not waste money in those areas. Obviously, you're not going to do this for 1 2 acre patches. A lot of these fields have 5 to 10. Our largest area would be about 45, 50 acres that we're doing this on. It is more time consuming, but again, we're trying to maximize that efficiency in those areas. We're doing some targeted herbicide applications in those areas as well. There's some costly herbicides like Edge that can help in those areas. Rather than apply it across the entire field, we're really targeting and maximizing, again, efficiencies of dollars spent in those zones. Again, with fungicide, it might seem not archaic, but a manual fungicide VR application. Within my sprayer, I can shut off sections of the booms. As I'm going over drawn-out areas, I can quickly do that on the fly as long as I'm paying attention. And that has definitely saved a lot of cost that way. And I think, when we talk about precision ag, it doesn't necessarily have to be within a field either. I think a lot of producers can maximize efficiencies on their farm. With Western Ag, what we do is a pretty intensive, fertility plan for farmers, maximizing every field, not necessarily every zone in the field, which is optimal. But if you don't have the technology to do it, maximizing every field, changing rates, maybe a different blend within the farm, but between fields, addressing small nutrient problems that can cause big yield losses between each field. So that's why I think the importance of soil testing is huge, and to follow that recommendation. Again, with that being said, logistics is a large part of farming. It doesn't matter how good your agronomics are if you can't put the crop in. So making sure that doing any of these plans, whether it be actual VR or just manually doing it as I do on my farm, you have to be able to implement this. And just keeping that in mind to not get too complex if you don't have the technology to do it.
Perfect. Thanks, Bryce. And yeah, I really appreciate your perspective on this. And again, just highlighting, maybe, so if, let's say, capital investment is a barrier, to adoption, maybe there are manual ways of going about it and still achieving the same end goal. So yeah, really, really appreciate you sharing that perspective, and look forward to continuing to hear from you throughout the other questions. So we've had the chance to hear from Wes. We've had the chance to hear from Bryce, and now I'm going to pose a question to Lauren. And again, with Lauren representing PAMI, again, PAMI has done a lot of research in the area of, equipment. And so just hoping to hear that perspective of, where research is at, sort of thing. So the question I have for you, Lauren, is, PAMI is actively engaged in ag machinery technology development and the validation of existing technologies. So I'm wondering if you can just tell us about a few of the projects in this area that you currently have going on at PAMI.
Yes, thanks, Blake. I appreciate the opportunity to speak on some of the work we're doing. In terms of the areas that we were working in and the seeding application, we're currently just completed a project here in 2020, looking at ground truthing sectional control with the Alberta Pulse Corers, trying to understand when I see a display and I have a percentage of overlap control, what does that mean physically when I'm looking at my field, and putting that into context for various applications. Again, trying to reduce that overlap and what options do I have to implement solutions to solve these kinds of things. Also looking at seed damage and monitoring and understanding through computer simulation, what can we do for air seeders and making adjustments, or when you make a change, how does that affect my overall operation of a system? Another area we're also working in here this past year and continue to work on as well is simulation of sprayers and understanding how your implement, when you operate it a certain way, what does that do for your overall performance in terms of spray drift? So trying to tackle that problem through some computer modeling as well as in-field validation. I think it's really important to not just look at the screen, but also look at the field and tie the two together. So not just looking at pictures, but understanding what does that picture mean in context of my field and my operation. So that's where PAMI, I think, brings a lot of value to these types of conversations. I guess one other area I'd point out as well, when you're looking at technologies, one of the things that we've done on the harvesting side is doing a survey of losses in canola in 2019 and taking a swath across the prairies of different machines, different vintages, in different operating conditions. And one of the real interesting findings for me was loss when you're looking at the age of machine. And we found that a well-set older machine actually can outperform a poorly set newer machine. So technology, if you use it correctly, can be beneficial, but you have to understand what you're trying to accomplish in order to obtain the goal that you're looking for in different aspects, whether it's seeding, spraying, or in the harvesting side. And that all comes down to putting grain in the bin and making sure that you have your grain in a safe storage condition and using technologies to help maintain quality, being able to dry and bin safely, and providing that overall context of revenue for the operations at the end of the harvesting season.
Thanks, Lauren. And something that just jumped out to me from your comments there, specifically on looking at harvest losses from the combines, and your comment on, a well-set old machine sometimes can outperform, a brand new machine, right? And I think what it speaks to is the fact that, we are seeing a lot of advances in equipment technologies, which is awesome, as we're seeing automation and different things like this that, helps the end user and maybe, reduces operator fatigue and all these sorts of things. But I think ultimately I do see the strong importance of, augmenting that technology with the human, ability to interpret what's going on, right? And to use that, experience and just the human potential of our brain to really set things properly. So no, that's very interesting comments. Thanks for sharing that. Wes, I'm going to go back to you now for this question. As we've seen historically, I think it's been tracked, through survey results and other things that some, precision ag practices have been adopted, quite readily on prairie farms already. Certain things like, GPS, auto steer, sectional control technologies, and those sorts of things. But I'm wondering, for those that are wanting to maybe explore other precision ag technologies, be it variable rate input application or maybe the use of hardware or sensors, where are some of the places would you suggest are maybe the best places to start, or from your experience working with clients, maybe give you that best quick win?
Yeah, well, the most important thing we always say is there's got to be two things that you've got to get right for it to be successful and ultimately provide value at the farm. And you've got to start with the right map, right? Like the right data layers. And then you've got to get the agronomy right. And the agronomy is sometimes difficult when it gets into complex things like fertility and nutrient interactions and whatnot. But, getting the map right, like it's as simple as the map or the zones, the management zones have to represent the response characteristics of the input you're applying. So something like an on-off fungicide in canola, for example, what we're looking for is a map that represents where the crop is poor and where the crop is good. And where it's good, it should get a fungicide, and where it's poor, it shouldn't, right? And so NDVI in that case is often a good base layer to use. It's that simple. On the other hand, with fertility, I guess we have a strong bias that if you're applying inputs to the soil, whether that's fertilizer or seed or even soil applied herbicides, you should start with soil-based layers. Okay, so we're a big part of our program would be utilizing electrical conductivity mapping, also elevation, topography, bringing all those layers together to produce the SWOT map that you mentioned earlier, that really affects all the soil properties that drive nutrient and seed responsiveness across the landscape. So it's where a lot of things have gone wrong is I think providers using base layers that were perhaps easy and inexpensive to get, but they weren't necessarily the right layer to use for the inputs that they were using it for. So you got to really get that map right, and understand that when it comes to fertility, like there's far more to nutrient responsiveness than just a soil test part per million, right? That's what we tend to focus on, is just those numbers, but we have to really appreciate the effect of water that drives mineralization and microbial activity and all those things. And it does get a bit complex. So my other advice would be to work with somebody with some experience and that knows what they're doing.
Great. Thanks, Wes. I'm going to go back to you for another question here too. And I think, you alluded to it a little bit even in your last response there. But, I think, again, just to have a real conversation here and a balanced perspective, I think we can all appreciate that, experimenting with different precision ag practices can be quite risky for farmers, right? So I'm wondering, what advice can you offer, again, from your experience, for those that, that want to get started, but maybe they're, feeling a little bit shy based on that risk, or maybe if they've had, a particularly poor experience, in their first attempt at it, maybe the weather conditions just weren't right for it, and it ultimately trumped, any kind of agronomic response that you were expecting to see in a so-called normal year or something like that. So I'm just wondering, if you can elaborate on that a bit for me.
Yeah, well, that's a good example. I mean, there's always those temporal factors that we're trying to manage spatial variability, but there's temporal variability that ultimately affects the end result, which is yield. So, and some of that's beyond our control, and there's extreme years. But first of all, I'd say, just always don't overthink it, right? And we're, as agronomists, we're guilty of that all the time. Get into the gory details of nutrient interactions and stuff and worry, but start with the easy stuff, right? It's if you've got salinity, let's get it mapped, understand where there's excess nutrients that we can afford to cut back on, and probably in most cases reallocate that investment to other parts of the field that we've likely been under applying, right? So yeah, just don't overthink it, and you don't need to go all in right off the bat. I think sometimes there's a mindset where, you need to do all these things, and we need to variable rate every single fertilizer product by itself, and a lot of the time that's just not realistic and causes logistical issues. And a lot of the time we can work within the restraints of what you're logistically capable of in the farm. So just start with the obvious opportunities and then work towards detail. It's not bang year one, you're going to just create miracles. It's a bit of a process. And it can take 2 or 3 years to work towards that. But over time, I think the benefits become pretty obvious.
Right. So I think, again, recognizing, that, as you noted, this temporal variability, the variation in climatic conditions, year over year can have such an, an important impact. But I guess for all of us, recognizing that sometimes it's maybe not going to work, but looking at sort of the long-term approach, I guess 9 years out of 10 or whatever, 8 years out of 10, you get those wins. But I guess then it becomes, tracking that over time really to, help inform that decision and sort of pull you through, those rough experiences when they might happen and those sorts of things. So yeah. Thanks for sharing that perspective. So I'm just going to remind for our attendees, feel free to be putting in any questions that you might have in the chat function. I'm happy, or our panelists are happy to be available to answer any of those, as we have time at the end of the presentation. So again, just feel free to put those questions in the chat anytime. So Lauren, I'm going to come back to you with a question here now. And this really came out of a conversation that you and I had as we were, preparing or thinking about this webinar. And really what it boils down to is, when it comes, in my experience, I guess it seems anyways, when it comes to, ag equipment, it seems that, sometimes the engineering and the technology is just incredible, right? And it's so advanced that it may be even, more advanced than what is actually needed by, practically by a farmer, right? So I'm just wondering if you can, tell us about the philosophy that you seem to have at PAMI by your team of engineers, and really, focusing on what is that problem to be solved, on the farm, and what is the problem that farmer has, and then, designing and thinking about solutions based on that.
That's an excellent question, Blake, and thanks for asking that. In order to put this in context, I thought, well, what's a great example? And I thought, Co-op Implements had their Chinook air seeder that had essentially hydraulic control, their metering drives that could be adjusted from the cab 30 years ago. You could do variable rate with that piece of technology. And it comes back to what else do I need to implement as part of this overall process to achieve the functionality that we're looking for. And I think there's 3 real steps that are really key to this process. The first being identifying what problem are you trying to solve. That has to be key. If you can't articulate what you're trying to accomplish, it's really hard to come to a solution. Once you've done that, then you'd find your problem. You can define what you're trying to accomplish by designing a solution based on the requirements that you want to accomplish from that. And if you do that well and articulate these kinds of things, then you can say, well, if I can test it according to these different parameters and quantify this, then I can say, yes, I've accomplished my goal, I've solved my problem, or no, I haven't, and these other things have come up, things I may not have seen initially that will help me point me to the direction and to the final goal. So that's really key, I think, is understanding what problem are you trying to solve. And once you've done that, I think the next important thing, and I'll have 3 points in this area, is looking at it from a systems approach. So not looking at things just in isolation, but understanding if I make a change in one area or I change a piece of equipment, what else do I have to do across my operations that may affect my overall operation, and take a real big systems approach. Just like as mentioned earlier about looking at logistics, that may be one of those limitations that you need to consider. So it's maybe not just your piece of equipment, but it's also the other parts that have to go along in order to make a full wholesale change to achieve the results that you're looking for. I think one of the last things I'd suggest doing too when you look at this and what PAMI does is bring a different perspective to the problem, and looking at it not just from an engineering perspective, but also from the agrology perspective from our team of technicians, agrologists, and mechanics that provide that unique perspective that only working and having hands-on application can really define a situation. I often use the analogy, if all you have is a hammer, then everything looks like a nail. I'm trying to take a step back from that and making sure that you're taking a big picture approach to some of these things and looking at, well, if I change this, what will be the impact from that perspective from different angles? So that's kind of the process we take at PAMI to solve some of these things.
Great. Thanks very much, Lauren. Going back to you again here for another question. In your position, I imagine you kind of have, the ability to, understand, what's maybe coming down the pipeline, broadly in terms of, the direction that equipment companies and technologies are going and that sort of thing. So I'm just wondering if you can share for us, from your perspective, what do you see on the horizon in terms of advances in ag equipment technology that farmers can expect to see? And I'll give you 2 timelines. So, the short term, so, in the next 5 years, let's say, and in the long term. So, maybe next 20 years, next 50 years. I mean, project as far out as you want to, as you feel comfortable to project. But just wondering if you have your experience, if you can share your thoughts there.
Excellent question. I actually want to put this in context too and go back to something that Blake mentioned earlier, talking about efficiencies and looking at this maybe from an efficiency perspective. When you look at energy consumption on farms, PAMI did a study looking at operations in the prairies. Number 1 energy input, fertilizer. Number 2 is pesticide, and number 3 is fuel. So tackling that in a priority list potentially is one way to put this in context of technologies and what we're seeing in terms of some of the advancements. And I think you look at what guidance systems have started from being a passive system that allowed operator to go in adverse conditions, not be able to see, to maintain control of their seeding operation, but also reducing overlap to where we are today looking at sectional control as a means to adjust our headland overlap as well as any obstacles. So those are the things that I think you're going to continue to see. And because of the drivers on efficiency, looking at your 4 R's for fertilizer, understanding how these technologies can impact what I'm trying to accomplish on my fertilizer, my fertility, my pesticide application. I think taking one of the next steps, we're taking a lot of data, taking our or going down a field every time. What about route optimization to manage fuel? So seeing new technologies come out in that kind of an area, using your data to help you manage your field operations more efficiently across all your paths. I think one thing in the near term as well is just more uptake of the currently available technologies that are out there. There's a lot of things that aren't being implemented. In the short term, that's going to be more of the change, I think, is implementation across a broader section of operations, looking at variable rate as one of those kinds of things where options are out there, technology is available, but uptake is less compared to, say, something like AutoSteer. And providing the information, I think, to operations and producers to understand what is my return on investment, what are my implications for implementing a technology like this in order to get the desired result that I'm hoping to occur. I think one thing as you start looking up more to the future in the 20 years and so on is the change in farm age, and your average age is mid-50s right now. And when you start going out 20 years or so, what does that mean for the average age of our producers, and what kind of changes are going to occur on a corporate level that may impact our equipment decisions because of that? Technology is advancing. Does that mean that every operation and every producer has to advance his technology level? Or is there going to be support that's going to be required in order to have service systems and service companies help support these more automated, these more in-depth type of operations and equipment and systems that go along with increasing technology and increasing complexity? I think that's one thing that you're going to start to see in terms of overall efficiency is some of the things in plant breeding and down the road, and increasing the overall operations and efficiency, but also I would say the automation side too. We're kind of at that point now where we have a hybrid, and I think that's going to continue. The operator is still a very good operator getting to the field, but you'll see additional advancements, I think, in terms of automated systems during the operation, allowing operators to take some of the load off them at that point, and maintaining that and making sure that you have control of your equipment. I just put out there one thing I think is data ownership and making good decisions, and using data and your equipment to help you as opposed to you helping to feed the machine, making the machine work for you and having that kind of a control aspect for that. So just some things to think about in the coming years.
That's perfect. Thanks, Lauren. So I do see there are some questions coming through the chat, so that's awesome, and we will get to those very shortly here. But I guess a final question that I have for Bryce, and it's really a two-part question, I guess. But you know, again, talking about that, the reality is sometimes there are barriers to adoption of precision ag technologies and practices. So I'm wondering if you can speak to your experience. You know, what barriers have you faced on your farm that have maybe prevented you from implementing some of these practices? And then, you know, how have you addressed some of these barriers, you know, to allow you to still implement those practices? So again, kind of going back to what you had alluded to earlier on the use of maybe, you know, a manual approach, but wondering if you can share your perspective on that.
For sure, Blake. Yeah, I might have a bit of a unique perspective. Being a farmer and working with lots of clients, some are variable rate capable and some aren't. So I kind of get a wide array of you know, some of the limitations I face as well as some of my clients face. You know, every farm is different. That's something that I've really learned working, you know, in the consulting business and working with a lot of different farmers. Every situation is different. For mine, you know, I moved home in 2013. We were 960 acres. We had a 29-foot FlexiCoil 5000 drill, TR98 and TR96 combine, and a pull type sprayer. We're just under 8 years later. We're 2,800 acres. You know, almost tripled in size. So in order to do that, we had a lot of capital investment that was required. I farm with an accountant, so you could imagine how much we scrutinize every dollar spent in capital investment. You know, there's a lot of farming's expensive. Farming is a very expensive venture. So we had to put a lot of money into, you know, other things like grain trucks, storage, land is a huge cost. We bought the drill we thought we could afford at the time, and we've used it since. That's something that in the future I really want to upgrade to a variable rate capable drill. But for us, it was capital expense was the main limitation to getting all of this technology implemented on our farm, and we're doing little bits at a time. You know, the other barrier I think that some of my clients talk to me about is which equipment is best. which brand, which metering system, for my land, which opener type, what should we be implementing on the farm? And again, every farm is different. Land varies drastically between areas. So, a lot of guys are kind of hesitant to know which equipment to put that capital investment into to really maximize their dollar spent and not regret it in 3, 4, 5 years, because we all know how much the value of a lot of equipment can drop. Another barrier, and Lauren talked about it a bit, is logistics, right? If you're using a single blend and that's all you can deliver to the field at seeding time, it's difficult to variable rate because your demand for different nutrients within the field is going to change depending on zone. So increasing nitrogen and phosphorus, that happens in a lot of areas. Decreasing nitrogen, maybe you don't want to decrease your phos. If you have a single blend, it's difficult to do that. One of the other ones I would think more so for my clients, for myself, I have a very good understanding of variable rate. I consult, I help write prescription files. Soil's complex. Like Wes said, sometimes you might overthink it, but it's a pretty complex thing, and it's a huge driver in yield and overall profitability. A lot of producers are inundated and overwhelmed with different VR strategies, VR mapping methods, how you implement that on the farm. What's the best way to approach this? There's a lot of different opinions out there. A lot of people are very, very strong in their opinions. And, I think you have to find the one that you feel most comfortable with. You have to find one that works for you and that makes the most sense. Full disclosure, I work with CropPro. They make my maps for my clients. I think they have the best system. And on my farm, that's what I'm going to be using once we are VR capable. Might not be the same for you. I hope it is. Just going by what I've seen that they can do. But everyone's going to have their own fit, right? Back to the first question, or the second part. How we address some of these barriers. For now, to maximize efficiencies and to implement a manual variable rate, I'm basically maximizing the efficiencies of what I have for equipment. What my farm is right now, I'm trying to maximize that, maximize dollars spent. Looking for the most return out of my inputs on every acre. Farming is very expensive. It's a lot easier to improve the land you have than to go out and buy new stuff. I have long-term strategies for capital investments in our farm. What the next step is, next purchase is, going forward from there. Just research the best options, I think, before you jump into variable rate. Have a pretty good understanding of what it is, the limitations of it, the benefits of it, how it's going to fit your land, and like Wes said, find somebody good to work with to implement it on your farm.
Perfect. Thanks very much, Bryce. So that really kind of closes the questions that we had that I had prepared for our panelists. Just one announcement before we go to the questions from the audience, and it just came up in the chat. You'll see, but again, we're pleased to offer a CEU credit for this presentation. So for anyone with that CCA designation that is interested in that credit, I just ask you to go to the offers section on the dashboard here. You can see the white dashboard. Along your options, there's the offers section, and if you click on there, you can scan the QR code. That'll allow you to get your credit for attending this session. So with that said, I'll just go to the questions, and we have a few currently. Definitely welcome any other questions that would come in, but the first question is from Rachel. And so again, I'll just kind of pose it to any of the panelists who want to jump in and take a stab at answering it. But Rachel asks, I'm wondering how seed testing can be used more effectively with precision farming. For example, a seed lot that has rapid uniform emergence where all seed is growing at the same time could be a better candidate for precision farming versus a seed lot that has variable emergence. So she's wondering what the panel's thoughts are on this. So, great question. I think it's something we haven't really discussed so far in this presentation. I mean, for what we did at Discovery Farm, we did variable rate. We varied the rate of our seed, to try to address, some of the increased mortality that we were expecting to see in some of our zones and that sort of thing. But I'm wondering if any of the panelists want to take a stab at that question.
Yeah, I could expand on that. And yeah, I mean, you mentioned we rated seed, and I think the results of that were obvious as to why we did it. I mean, we've recognized over years and years of doing plant counts in different areas of the field that mortality varies a lot. And a factor in that involves seed vigor and germination rates and stuff. So, I mean, every one of our clients that varies seed rates, or even if they don't, frankly, I mean, we'll consider seed test quality info like vigor and germination to figure out the proper NTKW, of course, to figure out proper seeding rates to achieve a target population, right? And that if they're VRing seed, that target population might be different in different parts of the field, right? So, and that's, driven by water really, or the soil potential. So, I guess that's how we're using it. We're along the same lines. I mean, we're also really intrigued by the potential to be screening hybrids and varieties of cereals out there on the market for tolerance to salinity or tolerance to acid soils, for example, and stuff. So then that starts to bring a real big opportunity for variable rate implementation, putting specific hybrids in certain parts of the field, perhaps, right?
Thanks, Wes. Any other panelists want to take a stab at that, or any other comments to share before we move on? Okay, no, that's perfect. Thanks, Wes. We have another question. It comes from Jordan. Jordan's asking, he's wondering if profit gains from the use of VR during seeding are currently limited more by air seeder technology, agronomy, and prescription map generation, or some other factors. So yeah, I guess ultimately, do we think it's more of a limitation on the technology side of things, or more the agronomy side of things? Wondering if anyone has a perspective on that.
Bryce, what do you think?
I think it's a combination, really.
Yeah.
I don't think there's necessarily profit limitations from equipment. I don't think there's necessarily profit limitations from the agronomy and the maps. I think it's the quality of the data that's entered into them and the quality of the person interpreting that data to make management decisions. I think a lot of the equipment we have is well capable of doing a lot better job than we are currently. I think there's a lot of maps out there that if you choose the right map and interpret the map correctly, you're going to maximize profit. At the end of the day, it's rain and sunshine that's going to dictate over profitability. But I think we have the technology; it's there. It just interpretation is the main factor, in my opinion.
Yeah, I think great comment, Bryce. I think the only thing that maybe comes to mind when I think about that, just again from the examples at Discovery Farm, was when we did our variable rate herbicide application as an example, and just sometimes it depends on the machine you have, of course, but I guess the resolution that you can apply a prescription can be limited by the capabilities of your equipment. In that case, I guess that's the only thing that comes to mind. But I'm wondering, Lauren, maybe to put you on the spot, if you have any perspective, again, from the work that you folks have done.
Right. Yeah, I was actually just going to add to that and echo what you're saying, Blake. I think it goes back to the study that we had on our combine loss and understanding your equipment so that you can make those informed decisions with the information that you do have and make good decisions based on that. It's really key to understand your capabilities in order to make good decisions for what you currently have before making other investments. I just echo too what Blake had mentioned earlier about looking at equipment and consider total cost of ownership. It's not just your purchase price, it's your operating, your maintenance, but it's also your selling price at the end. So that total cost needs to be considered when you're going to make any decisions in terms of equipment, because the capital investment is tremendous and it can really affect what the overall revenue potential can be for operations.
Yeah, that's great perspective, Lauren. Question from Henry. Henry is asking, he says, you were talking about salinity soils. So my question is, would black gypsum or humic acid fix these soils faster or more effectively? So I guess I'm just wondering if maybe, especially for Wes or Bryce, if you have any experience, working with either of those products that you can share.
Yeah, not a lot. I've certainly paid attention to it. Salinity is a water problem, and it's far bigger than anything you can buy in a jug, or in bulk for that matter. That being said, we do see situations in, say, peat soils where the EC tested at the lab would be like relatively high and indicate really a salt issue, and yet the organic matter seems to somehow buffer the effects of those salts. But that's a really unique situation, and you're talking about literally like thousands of tons of organic matter and humus in a soil, in a few inches of soil. Not a liter an acre or a few pounds an acre of a granular humic substance. So not saying they don't have a place somewhere, but everybody has to recognize that salinity is not just some easy fix, right? It's a major issue created by Mother Nature largely. So
yeah, I might just add to that. Good point, Wes. Yeah, my experience when we're talking about salinity or eroded knolls, any of these really problematic areas in the field, you have to look at what the background problem is, fix that. There's a lot of optimism that a small amount of a product will fix a big problem. Unfortunately, that's not the case. I think many little hammers to solve a problem than one big one is kind of what you have to look at in addressing a lot of these issues. There might be some products that can help alleviate some of those issues. All depends on the characteristics of the problem. But yeah, it's difficult to say that one thing will fix it in every situation, broad brush, right? Yeah, I think that's a very good point, Wes.
So we've had another question come in from Jason. He's asking, of the VR technology available, which will give you the best ROI for someone starting out? Should I look at outfitting a sprayer for VR fungicide top dress or a seeder for VR nutrient applications? So yeah, just wondering if anyone has a perspective on that.
I guess maybe I'll just start. I'd say, well, I think one of the challenges in agriculture right now is a lack of information. If you want to buy a used car, you can go to multiple sources to find that information and have different opinions on that. I think there's a gap in terms of that information, and it's available for producers to make decisions. So it really comes back to their own operations, understanding what you're trying to solve and look at options that maybe could provide the best fit for that solution.
Yeah, I've had to think about this pretty hard actually before I answered. The one thing about VR capability in a drill is it allows you to do more, right? So you can start variable rating phosphate, even micronutrients, seed, whereas through a sprayer, you're sort of limited to fungicide and maybe just top dressing nitrogen or sulfur. So I don't know. It really depends. It depends. I hate that answer, but it's the right one.
Yeah, I'm thinking maybe just again from strictly based on experience at Discovery Farm. I think I would echo the VR seeder just because I think fertilizer has such a tremendous portion of the total operating expense, I think, for farmers. So that's where I would maybe throw my support behind. But no, that's good. I see our time is quickly dwindling here. So I do want to just thank all of our panelists again for participating in this session. I think I'll offer on behalf of them that they'd be happy to continue the conversation with any of the attendees to the webinar and those sorts of things. And I think if they're in agreement with it, we can share their contact information as well so that they can continue the conversation. We did have one final comment here come in from Johan before we close the session, and it's on the topic of have VR maps for compost or lime. Is this commonly used in Canada? And I know that especially lime is commonly applied, globally to deal with the acid soils that typically persist. I mean, I think in Western Canada, because we largely do have quite high pH soils, not all that common of a practice, but I'm wondering, Wes, maybe from your experience in Alberta there, do you see anyone starting to dabble in that space of doing, lime application or?
Yeah, definitely. Yeah, I've got one client that's using amendments, compost, and wood ash. So wood ash is kind of replacement for lime. I mean, where they happen to be located, it's easily accessible, very cheap, and yeah, it's really happy with it. I mean, we see in Alberta here, at least anyway, very strong relationships of pH to the SWAT zones. So yeah, it's working really well. I think big opportunity.
So is it a tool used to help manage nutrient availability, or maybe like disease and pest disease issues? Like I'm thinking clubroot, that sort of thing, or what from your experience, what's the end goal with it? I'm just curious.
Yeah, well, so clubroot is sort of a side benefit part of it, I think, because there's a relationship to clubroot risk and pH and maybe calcium nutrition as much as pH. But yeah, I mean, it's just nutrient use efficiency. I mean, we've got a lot of soil pHs that we're finding in maybe small parts of the field, but we're getting 4.8 pH, 5.2, lots of that in northern Alberta. So that's problematic. It's holding back yield potential, and it needs to be fixed. Again, there's no $5 an acre something in a jug you can buy to fix that. It just needs lime or wood ash. So
perfect. Well, thanks very much. Again, as our session is coming to a close, I want to thank all of our panelists. I want to thank our attendees for joining us this morning and for sending the great questions in. Just a reminder that this session was recorded, and all the attendees will be receiving an email that with a link that they can rewatch the session at a later time if they would choose to do that. So just the final closing comment, I just want to encourage all of our attendees to give us feedback on this specific webinar, but also on what we're doing at Discovery Farm. I encourage you to go to our discoveryfarm.ca website if you're interested in learning more, and you can find our annual research report on that on the web there, where you can learn about all the projects we had at Discovery Farm. So with that, thank you all for joining this session, and stay tuned for other webinars that we will be hosting over the rest of the winter. Thank you very much, everyone.